Okay, so we had talked about last time that S is a distance around a portion of the edge of the circle. And if we wanted to find how long that is, the formula for it is S equals R theta, right? And remember, when you're using that formula, theta has to be in radian, right? Because this comes from the definition of a radian. So theta has to be in radian. Okay, so take a look at this question. It says find the length of the intercepted arc, okay, the length of the intercepted arc, that's S, in a circle with the given central angle and radius. So we have a theta here, which is 125 degrees. The first thing we want to do is change that into radian. And to do that, we multiply times pi over 180. And when that reduces, we get 25 pi over 36. Okay? Second, now we need to find S, which is R theta. So that's R, 7 centimeters, times theta, 25 pi over 36, which is equal to 15.3 centimeters. Okay. Next, if we have a portion of the circle like this, all right, that entire portion is called a sector. And to find the area of a sector, the formula is half r squared theta, where again, theta is in radian. So to find the area of this circle, of this sector, right? Let's see what we have to do. So here it says find the area of a sector of a circle with a given angle and radius. So the angle here is 60 degrees. Again, I need to change it to radians, so times pi over 180. And when the zeros cancel, that's just pi over 3. So area is half r squared theta. That's half. R is 8 squared theta pi over 3. All right, so that is half of 64 times pi over 3, which is 32 pi over 3 feet squared, or in decimals, 33.5 square feet. Right. So if we look at a sector then, okay, if this is a sector, that's a linear distance, right? When you measure that distance, it's in meters or feet, like you were walking in a straight line. It's just a curved line, okay? So once you have the distance that you've traveled, if you want to find your speed, well, then it's just that distance S over T. We call that linear speed because it's the speed of you walking along that line. And linear speed is given by V equal to S over T, the distance you walked divided by the time. Now, in walking along that green path, what are you also doing? You're also rotating about an angle theta, right? You're making that rotation. So suppose that angle theta was, let's say, 60 degrees. Now, how long does it take you to cover that angle of 60 degrees, right? 60 degrees divided by the time it took you to cover that. That is what we call angular speed. That's the rate at which an object rotates about a fixed point. Angular speed, right, because linear speed is given by V, angular speed is given by a Greek letter, and it looks like this. It looks like a curly W. It's called omega. Omega is how much of an angle you make divided by the time in which you make that angle, and it's given by this formula, theta over T. Okay, so if we look at this formula, this problem now, it says we are given the angular speed of a rotating object. What we want to find is the rotation, which is the same as the angular speed, in revolutions per minute. Okay, So what we're given here are units of radian per second. We want to have units of revolutions per minute. So essentially what we need to do is just a unit conversion from radian per second to revolution per minute. Okay, so we write down what we have. Okay, always start with the quantity that you're given, and then we're going to convert. So here, the radian is going to convert to revolutions and the seconds to minutes. So two separate operations. First, I want to convert radian to revolutions. So I do times fraction bar. And what's the relationship between radian and revolution? Well, one revolution around a circle is 2 pi radian. So I'm going to bring that relationship and put it here. If radian are on top here, it needs to go on the bottom here. So 2 pi radian, 1 revolution. Times. Now I want to convert seconds into minutes. What's the relationship? 1 minute is 60 seconds. Seconds is on the bottom here. It goes on top here. 1 minute. So finally, when radian cancel and seconds also cancel, you end with revolutions per minute. Okay, the values in the numerator are 2 times 60 over 3 times 2 pi revolutions per minute. And so here the 2's cancel and the 3's, you get 20. So this is 20 over pi revolution per minute, which is equal to 6.4 revolutions per minute. Okay, so next we have a wall clock here with a face diameter of 7 inches. We're told that the length of the hour hand is 1.7 inches, the minute hand is 2.5, and the second hand 2.8. And what we want is we want to find the angular speed and the linear speed. So omega and v, right? So remember, omega is theta over t and v is s over t. That's what we need to find. Okay, so, and we want to do this for each hand. So let's start with the hour hand. So the hour hand, if it was at, 12 o'clock, in 1 hour, it'll move from 12 to 1, that much distance. And if you look here, that whole thing is 360. But in that 360, there are 12 divisions. So in 1 hour, the hour hand moves 360 over 12, which is 60 degrees. Okay, that's the angle that it makes. I'm sorry, that's 30 degrees. Right, so 30 degrees in radian is pi over 6. Okay, so that's my theta. Right, to find angular speed, omega is theta over t, and the angle that it makes is pi over 6 in 1 hour, pi over 6 radian in 1 hour. So this is pi over 6 radian per hour. The linear speed is v equal to s over t. But what's s from before? S equals r theta over t. Okay. How much is r for the hour hand? 1.7 times pi over 6 over t. So that is 0.89 inches per hour. Right. So what about for the minute hand? If we go back on the clock, the minute hand, which is this one, in 1 hour goes all the way around the clock and it makes an angle of 360 degrees. So in 1 hour, it makes 2 pi or 360 degrees. Okay? So that means omega, which is the angular speed, is theta over t. It moves an angle of 2 pi in 1 hour. So that's 2 pi radian per hour. Okay, the linear speed, v, is s over t, which is r theta over t. And r for that is 2.5 inches times an angle of 2 pi over 1 hour. That is 5 pi, which is 15.71 inches per hour. Lastly, the second hand, now that's a different story. Okay, so in 1 hour, it makes an angle of, let's see. So let's take a look at where the second hand is. This is the second hand. In 1 minute, it goes around the circle 360 degrees. In 1 minute. So 1 minute, 360 degrees. But in 1 hour, it does that 60 times. So it's 60 times 360 or 2 pi. So 120 pi. So then if omega is theta over t, it's 120 pi over 1 radian per second, radian per hour. And then remember we said v was r theta over t? Well, the r here is 2.8 times 120 pi over 1 hour. That is a speed of 1055.58 inches per hour. Okay, so in this last problem, we have to find the area of the shaded region. And you see here, there is a combination of different areas here, which are going to add to make the shaded region. All right, we'll take a look at this first one here. That's a tiny little sector. And I'm going to call that sector 1. And notice, if I ignore the larger circle at the top, that's just a standalone sector on its own, which is very easy to find the area of. Okay? And then what I also have is this other region here. But this, I can't find the area of that strip on its own. That's actually part of another sector here with a different angle of 104. But the problem here is that if I find the area of that sector, I also take with it some of the blank parts, so then I have to do some subtracting. Okay, so there's lots of things at play here, so we're going to divide and conquer. First, there are two angles. Let's first convert those to radian. So theta 1 is 88 degrees times pi over 180, that's 22 pi over 45. Theta 2 is 104 degrees times pi over 180, that's 26 pi over 45. Okay, now let's find the area of sector 1, that little sector there. That's half r squared, r over there is 8 squared, theta So the area of sector 1 is 49.15 centimeters squared. Okay. Next, the area of sector 2 is here. So when I find the area here, I'm going to find it of that whole thing, right? So that's going to be half times this radius here, that entire red side. Well, how big is that side? Well, this part is 12 plus another 8, so that whole thing is 20. So half 20 squared times the bigger angle. And that is 363.03 centimeters squared. Okay, now again, when I did that, I found this entire part. Okay, so I have some extras in there. Namely, this blank part, I need to subtract from it in order to take that strip. So what about this? Okay, we'll call that sector 3. So let's find the area of sector 3. That's half. What's that radius? 8 squared times 26 pi over 45. Area of sector 3 is 58.08. Okay. So now, this shaded region here, I'll use black for that. This shaded region here, right? I'm going to subtract these two. 363.03 minus 58.08. That will be 304.95 centimeters squared. And finally, total shaded area is the sum of this plus this, 49.15 plus 304.95, for a total of 354.10 centimeters square, and that is the area of the shaded region. All right. Okay, one last thing for homework. Remember that if two angles are complementary, they have a sum of 90 degrees or pi over 2. And if two angles are supplementary, they have a sum of 180 or pi. Okay, so that's some topics from geometry. All right, thank you very much, and I will see you next time.